we're talking about regular figures, and again, what two things make a regular figures? What did I just say? They have to have two things. All sides are the same, so all the sides are equal, we could say, and all the angles are the same, or all the angles are equal.
You mean a regular polygon?
A regular polygon, yeah, we could say regular figures, regular polygons, it all means the same thing. Okay, so when we do this, a lot of times it's hard to find the area of things. We know how to find the area of squares and triangles without these formulas, but they can give you problems where you couldn't do it with your normal formulas anyway. So that's what we're going to work on first, is the triangles and the squares, and then we'll move to a hexagon. Now, there's some background information we need to remember. If we're trying to figure out what one of the angles in a polygon is, one angle in a polygon, in a regular polygon, do you remember that we had a formula for that? And y'all took a little quiz over it. It was n minus 2, number of sides, minus 2, times 180 divided by the number of sides. Y'all remember that? We didn't put it on the test, but we took a little quiz over it. So we may need to use that on some of the figures that we're not familiar with. We're pretty familiar with a triangle. A regular triangle is an equilateral triangle. We already know what the angles in that are. What are they? 60. So we already knew these had 60-degree angles. What are the angles in a square? A square is a regular figure. All the angles in a square are 90, right? So we won't need to use that formula for triangles and squares, but we might need to use it for a hexagon, because we might not just off the top of our head know what that number is. So we may be doing that today. When we get to hexagons, we will be doing that, as a matter of fact. Except they kind of give it away on the paper, so... Okay, the other thing we need to know is a formula you need to write up at the top of the page. If you look at the top of this page, you could have written regular polygon, all sides and angles equal, if you were filling this in. The apothem, you need to write that definition in. It's the distance from the center of the figure to the midpoint of a side. It's a perpendicular sort of height. It's always perpendicular. It's not the whole height, though. It's the height from the center to the side, okay? And it always cuts it in half. The reason we need to know what the apothem is because when we have these regular figures, how we find the area of them, the formula is 1/2 the apothem times the perimeter. So A stands for apothem, and P is the perimeter of the figure. So you got to figure out the perimeter before you can find the area. The apothem is not the radius. R would be a radius. A radius would go from the center to a vertex. And I'm going to show you why. What's not on this paper, it's helpful to know, is that all these figures, you would construct them by drawing a circle and then making equally spaced arcs, depending on how many vertices you have. And that's how you would actually draw one of these if you wanted to construct them. For instance, 360 degrees divided into 3 arcs means that each one of these 3 arcs is 120 degrees. That's not really going to help me here too much. Well, it could if I didn't know what an angle is, but I do know all these angles are 60 degrees, right? So I'll just write 60 degrees in here. So if I look at the center of the circle, that's the same thing as the center of the figure. I'll draw the center of the circle. It's the center of the figure. The apothem would be a perpendicular thing down here, so I'll put A on it. But a radius, I'll make it green, would be like that. It would go to a vertices. It would go from the center to the vertex. I could have drawn it to any of the sides, any of the vertices. I'm just picking one. Now, what happens in these problems is instead of giving you helpful information like the base and the height, they tell you the apothem, and that's all you get. So a lot of people think, oh, well, the apothem's right here. I know the height. I can just double this. But that's not, if I double that, that's not the height, because look, the apothem is just from here to here. It's not really a radius of the circle. It just goes this far. And a radius, if I were to draw the radius in green, and I would go up, it would hit right here. The height would actually be the radius plus the apothem in the triangle. So, you know, a lot of people think they can just double the apothem and they've got the height, but that's not true, okay? Because the radius and the apothem, they're two different things. So let's look at this problem, knowing that A stands for apothem, P stands for perimeter. All right, so if I look at this again, if I draw it again, it looks more isosceles, but we're going to say it's equilateral. They tell us on number 3 that the apothem, A, is 2. They actually label it on the figure. And if you look at your figure, I'm going to blow that triangle up a little bit so I can write on it, because it's too hard to get this stuff to show up that little. This is the 30, 60, 90 triangle. The reason I know it, if I didn't know, if they hadn't labeled it, I could have told what that was, because isn't the whole angle in an equilateral triangle 60 degrees? Well, when you draw that radius in, it actually bisects that angle. So that's why it's 30. And so if you got a perpendicular height in the apothem and you draw the radius in, it cuts that 60 degrees in half, and that's where we get that 30 degrees that's in that triangle. Now, I'm going to go ahead and label 2.
Across from my hypotenuse, it's 2A.
Well, I got to be careful. That is my, okay, you know, normally when we label, we use A, don't we? Let's not use A here because we got A as the apothem, right? Yeah, let's use like X's or B's or something. We can use B's if you want to. So across from 30 degrees, I'll label that B. Across from 60 degrees, it is B squared of 3, and across from this is 2B. Now, how's that going to help me?
You plug in the 2 where the B is, and then you get your answers.
Well, not totally the answer, but it's going to help me, okay? So 2B would be 2 times 2 is 4. This B squared of 3, if I plug 2 in for B, because I know it's, well, again, we don't want to use decimals, okay? We're trying to be really exact. We're going to use these radicals in all of our answers, just like we would have them when we labeled it anyway. Okay, so now, how's that going to help me? Well, I know that this side, right, this piece right here, isn't that just this on the triangle? And it's 5 square roots of 3. This other piece is also going to be 5 square roots of 3 because the apothem and the radius both do bisecting. The apothem bisects the side even though it doesn't look equal the way I drew it, but it does on your paper. So this is also 5 square roots of 3. So if I want that whole side there, it would be 5 square roots of 3 plus 5 square roots of 3, which is 10 square roots of 3 for one side. Sorry, it should be 2. Thanks for catching that. Let me correct it in red. This is 2 square roots of 3 and 2 square roots of 3. Yeah, so it should be 4 square. Thanks. Now, how does that help me? If you think about your formula.
Well, area is base times height.
Yeah, it's a half. Area is a half apothem times the perimeter. Okay, we now know the apothem. We knew it was 2. We just really needed our perimeter. And if one side is 4 square roots of 3, aren't all the sides equal in a regular figure?
Yeah.
So couldn't I just say the perimeter is 3 of those, right? So it would be 3 times 4 square roots of 3. And again, you multiply, when you're doing this kind of multiplying, you multiply the numbers on the outside together, and you can't multiply the number on the outside with the number under the radical. So it would just be 12 square roots of 3. You can only multiply numbers under radicals with other numbers under radicals. In case you don't remember that, I just wanted to point that out since it's going to be showing up so much. So my perimeter goes right here. They wanted me to find the perimeter. Well, I had to do it in order to find the area. So that's one of the good things about it. It's not like you're working toward the same goal with it all. And then we've got our area here. Do you have a question, Misha? Yeah, bad timing, because I was hoping y'all do take, yeah, go ahead. Half times 2 is 1, and 1 times 12 squared to 3 happens to be 12 squared to 3. So that's our area, and it's units squared. They didn't give us the units here. Oh, they did. No, they didn't. So